Okay, today we're going to use what we know about trig ratios and use that information in conjunction with angles of elevation and depression to find lengths, distances. The first thing we've got here is, what is an angle of elevation? It's an angle formed by a horizontal line and an observer's line of sight to an object above the horizontal line. So our diagram here, we have an angle of elevation, and I'll draw this in red. We have our horizontal line right here. We have our line of sight above that horizontal line, and this angle right here we can see is the angle of elevation. On the other side of that, we have an angle of depression. That's an angle formed by again, it's still a horizontal line, but this time an observer's line of sight to an object below the line. So we have another horizontal line, but the line of sight goes below that horizontal line, and that is our angle of depression. Depression going down, elevation going up. So here we have a picture of an angle of depression. We've got someone in the helicopter looking down from that horizontal line, creating this angle of depression right here. Now, what angle is that? Angle L. We can name it one letter because it's the only angle with that vertex. And again, in that case, it would be an angle of depression. Now, on the other side, we have someone standing looking at the Ferris wheel. There is the horizontal line. They're looking above that horizontal line, creating this angle, which is angle W, and that one is an angle of elevation. They're looking above that line. So let's look at one of these word problems. We've got a person watching a hot air balloon ascend. So we'll say that the person is standing right here, and the hot air balloon is over here, and it's going up. The viewer's line of sight forms a 90-degree elevation, or 20-degree, angle with the ground. So they're looking up, which is an angle of elevation, and that angle of elevation is 20 degrees. Now the balloon is 1,200 feet above the ground, so the balloon is up here. How far is the viewer from where the balloon started? Well, that distance from here to here is what we're looking for. Well, we'll notice that this forms a right triangle, and we'll call that Y. And what that does is it creates, we can use a trig ratio to solve that missing side. This would be the hypotenuse in relationship to this angle. This would be the opposite side, and this would be the adjacent side. So which ratio, knowing that we have the opposite and the adjacent side that we're looking for, uses that in regards to SOHCAHTOA, that would be TOA, which is the tangent ratio. So we would say that the tangent of the angle, which is 20 degrees, is equal to opposite over adjacent, and that's what we have. We multiply times Y. And then we would, which would leave us with, let me kind of move this over. That would leave us with Y times tangent 20 equals 1,200. We would divide, because we want to isolate the Y, by tangent 20, both sides. So Y equals 1,200 divided by tangent 20. And when we do that, if we were rounding it to the nearest whole number, we would find that that length from the person to where the balloon took off would be 3,297 feet. Okay, another one. Oh my, that's not moving, is it? Thought it would. Here we go. Let's do this. was weird. Okay, so now we have another situation. We have a lighthouse keeper at the top of a 120-foot tall lighthouse. So here's the lighthouse. The base is at sea level, and there's a boat a certain length away. So the sea level, the lighthouse is 120 feet tall, and there's a boat a certain distance away. What's the horizontal distance between the base of the lighthouse, right here, to the boat? We'll call that x. So we need to find that length. It creates a right triangle. And notice that it says that the angle of depression is 5 degrees. Well, that angle of depression is based on the horizontal line going down. So that angle is 5 degrees, which means the angle that we're looking for right here is 90 degrees, because this forms a right angle. 90 minus 5. So this angle is 85 degrees. So we've got the hypotenuse, we've got the opposite side, and the adjacent side. We've got 120, and we're looking for this angle. So what we're going to do is use adjacent and opposite, which again is the same thing. TOA, opposite over adjacent. So the tangent of 85 equals opposite x over adjacent 120. Multiply both sides by 120 to solve. We end up with x equaling 120 times tangent 85. When we solve for x, we find that x, rounded to the nearest whole number, is 1,372 feet. Okay, the whole assignment is nothing but word problems similar to that.